Hello, everyone. Happy to be live today from Infovista. Here with a few product experts from iBwave and Infovista to have a big topic today that we're discussing. And thanks for joining today, everyone. We're here with Darren Hart and Zach Elias, product experts from Infovista and iBwave, to look at some of the most innovative new use cases around indoor and outdoor planning for connected campuses, including a quick demo of iBwave and Infovista's new integrated solution that we're going to look at later. So drop in your questions along the way, and we'll get to those at the end. But yeah, let's roll into it. I'll put up the presentation.
Thanks a lot, Ryan.
Hi, guys. Well, welcome to this short LinkedIn here. So we're talking today about bridging the gap between indoor and outdoor wireless with a new solution we're going to be offering from obviously iBwave and Infovista, as Ryan said. So what is the gap we're talking about? I think, to get forward here, is basically, as you know, in the world today, and if you come from the indoor world and talking about DAS and analog DAS, we tend to look at in-building solutions as siloed from outdoor solutions. Outdoor solutions tend to be things like MNOs, so your mobile network operators, etc., building very large macro networks. In-building solutions can, of course, be specialist projects for those companies, or potentially projects for public safety, of course, and other things like that. As we've moved forward into the next generation of wireless, which is now 5G or NR, as we call it, we've looking at this concept and paradigm shift of these large macro cells becoming much smaller and much more concentrated, if you like, into a much more microcellular style network. And it's really bringing down that wall, or starting to impact that gap between what would be intrinsically in the past an indoor network and an outdoor network, leading to basically a need to model those in a unified way. So Infovista and iBwave decided to join our large experience base together. Basically, obviously, in iBwave having much and being the leader in that space of indoor, and Infovista being a primary player in the outdoor space, decided to come together with our many years of experience to basically build a solution for our combined customer base that will give them good, active solutions based on our experience.
Yeah, this relationship between us, just as a note, it's more than just expertise. Obviously, the expertise between us is great, but we are each dedicated in our core functionality, indoor and outdoor. Combining the two not only combines technologies independently, it's also combining ecosystems and things that are hard to build up, like the library of components necessary and so on.
I think that's a great point, Zach. I mean, basically, we know there are other players in the field, but we both know our areas in a very high level and a very deep understanding of our areas of expertise. We deal with our customers daily on those areas. To bring two companies together gives the best solution for our combined customer base. We're not basically a company looking at a new area. We're two companies joining together in this area to improve our combined solution. So what does the new products give you? So this is Reach and Connect from Infovista, or Reach from iBwave. Basically, the ability to model these types of campus-style networks, which are becoming very common in our space. Obviously, campus is a broad term, but it could be anything from an enterprise-style building or buildings. It's very common now, especially with the rollout of private LTE in the CBRS band. We've got to look at modeling SaaS, distributed systems in a different way. We need to know how they will interact with the exterior networks. Obviously, there's use cases that in-building people are very used to, things like stadiums, hospitals, etc., and areas where the outdoor crowd now need to monitor and take those into consideration within their own networks for things like interference, parameter planning, for things like control of the channels, etc. So we need to be able to model these in a much more coherent way than we have in the past. So we're going to look at one use case here today, just to show you, and I'll let Zach talk about that in more detail.
Hold on, just a quick note here. When you talk about anything, when you talk about campuses, there's a lot of repetitiveness when you look at things like a high-rise building. You could have a client on one floor and have to do design and a walk test, and then have to potentially repeat that on each and every floor because you don't really understand the impacts of the outdoor on the indoor, or vice versa. So there's a lot of cost savings in a lot of these campus environments, especially when you start looking at both the indoor and outdoor, which is why campus is one of the major items we've been looking at. So yes, go ahead and we'll talk about one thing and I'll show a demo of it as well.
And I assume there's a large time saving there as well, Zach. I mean, if you're looking at the expense of walk testing and going out and arranging to walk many floors of buildings and potentially multi-buildings, that could be a large time saving as well.
Yeah, absolutely. Especially when buildings can be very similar between one building and another. They're all prefab or at least cookie cutter designs. It's not necessary to do the same thing over and over again. So a campus. In this case, let's take a look at a large corporate campus. And here you have generic problems that you would expect. I mean, you have a high traffic of users that are potentially going from one building to another. This could be corporate or it could be educational campus, but you get the idea. Overall, this is a major case and it's a keystone item when you talk about indoor and outdoor because of those characteristics of people doing their work on the indoors, and what they expect is a seamless experience when they step out of their office and go to the building across the street. And that's where design of both the indoor and outdoor makes a lot of sense. So let's take a quick look at what this actually looks like. So this here is a campus. It's in an urban environment, and if you want to take a look at it holistically just from an outdoor perspective, you can. And this is what you can do in Reach. You can actually look at the RSRP coverage, and it looks at each of the buildings, and it has assumptions about every building. The buildings themselves, there's no real understanding of what happens on the inside, and that's typical of just outdoor use cases. And here you have coverage on the indoors, but there is a perspective on the inside, and that's where the iBwave design side comes in. You can take a look at that exact same floor in that building, understand the characteristics inside the building. It's not just materials outside, but it's materials inside. And here you can actually see that same outdoor view. This is what we get when we first exchange information. We're looking at the exact same assumptions about materials and so on, but that's not what people want. People want to understand what that actually looks like on the indoors. So understanding materials then gets you this perspective, which is an indoor perspective of what the outdoor signal is doing. And this is all based on material characteristics. So you can look at this in 3D and see that what the characteristics are and why. It could be that there's concrete, there could be windows, there could be other materials in the way. And all of this is giving you insight of just that impact from outdoor to in. I'm just going to flip it around here, and you can see here that this is where that actual source is coming from. It's coming from the upper right side. And if you take a look at that and then start to try to take a look at what the impact of that is on the indoor network, you'll see this kind of picture, which is the dominance picture. Right now, I'm showing that my indoor network is green.
So Zach, that's really important to in-building designers, right? So if you can see the actual true dominance from an external cell coming in, that may make quite interesting design choices you need to make to overcome those dominance issues and potentially change your design.
Absolutely. So in this case, it kind of looks evident as to what needs to happen. You need to move particular cells a little bit further up to improve that indoor coverage and then try to counteract what's happening on the outdoors.
Interesting.
So right now, what you've seen is just that outdoor impact from here in, but now we're going to start to move in the other direction, which is how do I get my indoor information back into the outdoor tool so I can see those interactions. So here is my indoor design. I have signal strength and RSRP coming from those cells. And on top of that, I also have an understanding of what the leakage outside of that building is. This is the indoor signal going out. And this is what I need to now look at from an outdoor tool perspective, what the interactions are from indoor to outdoor. So here's that same building, and this is that old view that you saw before. And now we're going to take a look at that same view, but this time accounting for indoor signals. And what we have here is now the small cell heat maps. In addition to that, the actual leakage that's happening outside of that building. Again, this is now accounting for the indoor characteristics of the building. And this can be done across all the various files and design files that you might have for an indoor file. You can see it for every single building here. You can see an indoor cell and how it contributes and potentially interferes with the outdoors. But it's not just RSRP. You can also look at other characteristics as well that are interesting to you as a designer. Maybe you want to see or prove what the best serving area is now. And here you can actually see that the best serving zones are marked as indoor, and then you can still see the outdoor cells as well as best servers. You can see that distinction now in the outdoor tool holistically across all the buildings. So that's something that is pretty interesting to look at.
Oh, that's really interesting. So that could be very important for MNOs, etc., who really need to define, where cells are serving correctly, make sure that there's no egress, building leakage, as you say, that could be impacting their micro and macro networks in the outdoor space. I think something to also note here is, of course, this may well be an ODAS you're designing as well, right? Between these buildings, it may not be an MNO or one of these cellular systems, may be a purely private network. And this tool would allow you to actually build a full ODAS and take into consideration things like the exterior buildings, trees, etc., in a more correct manner. Okay, okay. So I think that brings us really on to what this was about. Zach, is really what we're solving for the users, and as I think we can see from this quick demo, the issue of dominance, which is obviously very high and central to in-building planners, normally having to build to a certain dominance on a floor-by-floor basis. This allows them to actually truly see if they are meeting that criteria, instead of basically designing to a DB, then going to walk that building, etc. Maybe having to come back and redo the design because the walk test didn't meet the criteria, go back with the design number 2 to whoever it is, come back, walk test the building again, come back, redo the design. Iteration 4, iteration 5 becomes very expensive and very slow. So you can see how these tools could really improve that. What do you think of that comment there, Zach?
Well, I think it's applicable to, especially now when you think of the 5G deployment that's happening. People need to relook at their designs. They need to look at them beyond what they were doing just for 4G. In some cases, they don't have a 4G indoor deployment. They're going right to 5G, and they need to understand the characteristics of materials because of millimeter wave, what's happening across a building corner, all of these things. And individually, we each provided strength, but collectively, we now provide that double strength between us both. This integration and this work that we've done to create Reach together has really going to give people an opportunity to do those kinds of cost savings, time saving, and so on when they're designing, which is very important, not just to an SI, but also to an operator, obviously, and to the end user, which is the actual person who's benefiting. They get to go, and there's something, a feel-good aspect of looking at your phone and still being 5G when you go inside of a building and outside, depending on where you are.
Truly become a seamless network. I think also something to point out here is, this could also be very impactful for the public safety crowd as well, especially looking at leakage. We always know there's issues when trying to build, for instance, in LA, where there's so many in-building solutions, start to impact the P25 networks as they try to all interact with the same cells. This could definitely help in those scenarios where they're trying to look at those issues with many different in-building solutions trying to impact with the same public safety cell systems in those locations. I think you can see the value of this product straight away from just this demonstration. Is timely and needed, and from my perspective, what iBwave and Infovista really bring to the table is a world of experience in our areas of expertise, and collaborating together gives us the best possible solution, because we're not starting from scratch in any one area. We're not an in-building company trying to build an outdoor tool, or an outdoor company trying to build an indoor tool, starting from scratch. We are the premier companies in our spaces, and taking full advantage of what we know in our spaces and joining those together to build a coherent solution that is really ready for our customers.
Right. And as product managers, we understand that there's development time and development resources in getting these things done. We're not scaling up. We've scaled up with a partnership, which is really important. We're moving independently with independent roadmaps that are collectively working together for a broad product. And I think it's one of the best solutions that we've got out there.
Yeah, I think it's very timely in the industry today. With that, Ryan, I think we'll hand it back to you.
Excellent. Yeah. So I guess maybe one question I would have, and what I'm seeing over here is, are there any of these points that you kind of wanted to tie back specifically to what we saw in the demo? Because I think there's two very interesting things we're describing here, which is, the solution is very powerful given our expertise and the actual technical sophistication of our solutions. But there's also that idea of, the partnership was set up in a way where we were trying to make sure, we didn't try to do something that we're not experts in by allowing, the indoor to be served by iBwave and the outdoor to be served by Infovista. So are there any of these points that specifically kind of tie back to something that was in the demo, to describe one-to-one how the technical kind of meets these value propositions?
Sure. I mean, you can see it straight away with the fact that reach and also if you was to acquire Infovista's Connect, are using very high level 3D modeling. So obviously designed over many years with much experience from the real world. So these are models that are defined and used by MNOs around the world. Very large organizations. So I will not name any, obviously, for obvious reasons, but these are tier one companies across the entire world that use these enhanced models. These are exactly the same models available in Reach and Connect that can be used in what Zach was showing you. On the flip side, I'm sure Zach will tell you exactly the same thing, where they have many years of experience in that space. They understand dynamics of materials in spaces, in indoor spaces, the complexity of that and how that impacts the signal that we may not have had the understanding of as an organization. So bringing those two together really gives us a very good realistic representation of the real world, and from that we can come up with very useful and efficient products for our clients.
Interesting. And then actually one question for Zach. Can these products be used to measure and import outdoor macro data for new construction building that hasn't even been built yet?
Yeah, absolutely. So what this integration provides is the import of that outdoor data, and then it can be applied to walls that you create up in whatever venue that you like. I mean, it doesn't have to be a building that existed. It could be completely raised to the ground. You want to build a brand new greenfield one, go ahead. You'll take that outdoor data, and with that outdoor data now understand what the impact is on the indoors. So we don't want to end up in a situation where you saw on that dominance map where you have a gap and then you have to go back and then redo infrastructure, replace a small cell, potentially add new fiber, all to make sure that you fix that issue. So even in a greenfield design, you can do that right from the get-go, build your building, understand what the impact is from the outdoor in, and still do that same interaction from the indoor out, and send that information back through Reach, and then see what the impact is on your outdoor design. It's completely independent of whether or not a building exists or not.
Interesting. And we looked at campuses today for people that may have joined a little bit later after we went through it. What other scenarios does this really apply to? I know we talked about interesting ones like stadiums, I know are a really big one. Are there any other ones that would be interesting to note?
I think there's many different, campus is a very generic term, but, any type of structure that's within the environment that would have both an in-building component, if you like, and an exterior component. So it really, the tools are designed to model that interaction between the outdoor and the indoor, if you like, a HetNet style environment, or trying to break down those walls to give a good solution. So I've seen very interesting solutions across, for instance, like raceways, so they're looking at very open spaces, but then they need to have a very detailed understanding of the stands, the stadiums, and what's underneath the stadiums, if you like, the back of house where, refreshments and things are. In an outdoor tool like Planet, for instance, you would not really be able to model that interaction. You'd be able to model the area of the exterior, and with iBwave design, you would not be able to model that exterior. So bringing those two together, and with Reach, you can actually see the interaction of both of those areas together. And I think that's true of any type of dynamic you put them in. It could be a raceway, it could be a stadium, could be an office, could be a set of offices, any type of, it could be a city block. It could be any type of scenario you can think where there's an in-building and an exterior interaction.
Okay. One more for Zach, actually. Do these solutions support indoor massive MIMO planning?
Massive MIMO on an indoor is an interesting concept. Typically, when you set up small cells, for the most part, they're not really massive MIMO in the sense that you would have in an outdoor setting. So in an indoor setting, we definitely support MIMO, and we do support it for handsets that currently exist today. The impact of massive MIMO from an outdoor cell onto an indoor is just an interesting concept. Generally, you don't want them to interfere anyhow. So yes, we support MIMO within the indoor concept. Massive MIMO is curious. I mean, I'm trying to imagine cases where that would really have an impact, other than perhaps if you have let's say, a very reflective millimeter wave scenario, then you'd want to worry about massive MIMO a little bit more. But obviously, MIMO is obviously anything that the handset currently supports is of importance to what happens on the indoor market.
Interesting. Okay, well, that's actually really interesting stuff. But I think that actually probably brings us. Well, actually, hold on. We might have time for one more question. Yeah, let me bring it back to Darren before we close. We'll get one last question in. Darren, is the MNO tower RF information available in some degree to the iBwave in-building design community, so they can model macro environments outside the building?
Yeah, that's a very good question. So it really depends on your ability and what work you're doing. So I'm assuming this question is the AT&T database, for instance, not to use them as a quote, available to anyone to bring into the tool? The short answer is not really, because obviously, unless you went to the FCC to see those towers, that information is proprietary to AT&T. But if you are working with them as a vendor, for instance, or them as a customer, they could very much give you that information. And there is actually tools that allow you to import that data directly into Reach in a quite an elegant manner. But yes, you would need to have access to that data from your client.
Interesting. Okay. Well, really great to have you guys on here today. Want to thank everybody who joined, and encourage anybody who has any further questions. Hopefully we can get back on like this again. This was a really interesting session. So if you have any questions, please reach to us in the comments on LinkedIn, and we'll respond to you later on. So, but for today, that brings us to time. Thanks, Zach. Thanks, Darren.
Thank you. No problem.
And then thanks everybody out there for joining today. We hope you'll join the next one. And if we didn't get to your question, keep an eye on our LinkedIn and we'll get back to you. But thanks for today, and everybody have a good one.
Thanks.
Thanks. Bye.
Bye, folks.